Imagine for a moment that you're an astronomer, eyes glued to your computer screen as data from the newest space telescope streams in. Suddenly, something catches your eye. A star doesn't quite look right. Its light is dimmer than it should be, and its spectrum is off. As you dig deeper, a chill runs down your spine. You're not looking at a natural phenomenon. You're looking at the greatest engineering project in the known universe, a Dyson Sphere. Welcome to All Sci-Fi What If, the show where we explore the most mind-bending scenarios at the intersection of science and imagination. Today, we're diving into a question that could redefine our place in the cosmos. What if we found a Dyson Sphere? We'll explore the concept of Dyson Spheres, the implications of discovering one, and how such a find might reshape our understanding of the universe and our future in it. We'll dive into various types of Dyson Spheres, examine the Kardashev scale of civilizations, and speculate on the profound implications of such a discovery. So strap in, keep your mind open, and prepare for a journey to the edge of possibility. Before we leap into the implications of finding a Dyson Sphere, let's make sure we're all on the same page about what exactly we're talking about. The concept of a Dyson Sphere was first proposed by physicist and mathematician Freeman Dyson in 1960. Dyson was pondering a simple but profound question. As civilizations advance and their energy needs grow, how might they harness the maximum amount of energy from their host star? His answer was audacious in its scale, a megastructure that could capture most or all of the star's energy output. The idea was inspired in part by science fiction, specifically Olaf Stapledon's 1937 novel Star Maker, which described a similar concept. Now, you might be wondering, why would an advanced civilization undertake such a monumental project? The answer lies in energy. As Arthur C. Clarke once said, any sufficient advanced technology is indistinguishable from magic. And what can be more magical than harnessing the entire energy output of a star? This brings us to the Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964. The scale classifies civilizations based on their energy consumption. Type 1 civilizations can harness all the energy that falls on their planet from their host star. Type 2 civilizations can harness all the energy emitted by their host star. Type 3 civilizations can harness the energy of their entire galaxy. Earth, for reference, isn't even a Type 1 civilization yet. We're at about 0.73 on the Kardashev scale. A civilization capable of building a Dyson Sphere would be approaching Type 2 status. So, when we talk about finding a Dyson Sphere, we're not just talking about discovering an alien artifact. We're talking about finding evidence of a civilization so advanced that they can manipulate stellar masses and harness the power of an entire star. Its prospect is both thrilling and perhaps a little terrifying. Now that we understand the basic concept, let's dive into the various types of Dyson Spheres that have been proposed. Each of these designs represents a different approach to the challenge of capturing the star's energy, and each comes with its own set of advantages and challenges. First up, we have the Dyson Swarm. Imagine a vast array of orbiting satellites or solar collectors, each one independently circling the star. This swarm of structures work collectively to capture a significant portion of the star's energy output. The key advantage of a Dyson swarm is its feasibility. It could be constructed incrementally, with each new satellite adding to the swarm's total energy collection capacity. This makes it more of a realistic first step for civilization embarking on such a mega project. However, the Dyson swarm isn't without its challenges. Maintaining stable orbits for millions or billions of individual structures would be a monumental task. There's also the risk of collisions between components, which could potentially trigger a catastrophic cascade of destruction. From a detection standpoint, a Dyson swarm might appear to us as a star that dims and brightens irregularly as swarm components pass between us and the star. We might also detect unusual infrared emissions from the energy collecting structures. Next, we have the Dyson bubble. Unlike the swarm, a Dyson bubble consists of stationary satellites held in place around the star by the pressure of its light. The primary advantage here is that you don't have to worry about orbital mechanics. Each component stays put, basking in the star's radiance and converting it into usable energy. The challenge, however, lies in the materials. We need to develop incredibly lightweight yet durable materials that could withstand the constant bombardment of solar radiation while remaining aloft purely through light pressure. To our telescopes, a Dyson bubble might look like a uniform dimming of the stars, possibly with some unusual spectral features due to materials used in the bubble's construction. Now we come to what many consider the classic Dyson Sphere, a complete solid shell encompassing the entire star. This is the ultimate energy capturing machine, theoretically able to harness 100% of a star's output. The advantages are clear: maximum energy capture, and a vast internal surface area that could potentially be habitable. Imagine having the equivalent of billions of planets worth of living space, all powered by a star at the sphere's center. However, the challenges of building a Dyson shell are immense, to put it mildly. The structural requirements for a sphere that could encase a star without collapsing are beyond anything we could currently conceive. There's also the problem of heat dissipation. All that energy has to go somewhere, or the spheres would quickly become uninhabitable. Because of these enormous challenges, many scientists consider the Dyson shell the least likely type to actually be built. If we did detect one, it would suggest a level of technological advancement far beyond even what we imagine for most Type 2 civilizations. Firstly, we have the Dyson ring, also known as a ring world in some science fiction. This is essentially a compromise between the swarm and the shell, a ring-shaped structure that orbits the star along its equator. A Dyson ring is more feasible than a full shell, while still providing an enormous amount of energy collection and habitable surface area. It's a popular concept in science fiction, with perhaps one of the most famous examples being the ring world in Larry Niven's novel of the same name. However, a ring would still face significant challenges in terms of stability and sheer quantity of materials required for its construction. To our instruments, a Dyson ring might appear as a star that dims periodically as the ring passes between us and the star, similar how we detect some exoplanets today. Now that we have a solid understanding of Dyson spheres and the Kardashev scale, let's dive into our what-if scenario. How might we actually discover a Dyson sphere, and what would the immediate aftermath of such a discovery look like? The most likely method of detection would be through astronomical observations. A Dyson sphere, by its very nature, would alter the appearance and behavior of its host stars in ways we could potentially detect from Earth. Here are a few telltale signs astronomers might look for. Unusual dimming. A Dyson sphere would block a significant portion of its star's light, causing it to appear dimmer than expected for its type and distance. Infrared excess. Even if a Dyson sphere captured all visible light, it would still radiate waste heat in the infrared spectrum. Spectral anomalies. The light that does not escape might show unusual absorption or emission lines due to the materials used in the Dyson Sphere's construction. Gravitational effects. A massive structure like a Dyson Sphere could cause detectable gravitational effects on nearby objects. Let's imagine a specific discovery scenario. It's the year 2035, and astronomers are poring over data from a newly launched ultra-deep space survey telescope. This hypothetical telescope, with its unprecedented sensitivity and spectral range, is designed to study the atmospheres of exoplanets and search for signs of life. As they analyze the light from a star about 1,000 light-years away, they notice something odd. The star's brightness fluctuates in a way that can't be explained by orbiting planets or natural stellar processes. Moreover, there's an unusual infrared signature far more than a star of this type should emit. Intrigued, astronomers around the world turn their instruments toward this anomalous star. As more data pours in, the evidence becomes undeniable. The star is surrounded by a vast swarm of objects, each one larger than a planet, collectively blocking and absorbing over 90% of the star's energy output. After months of observation and debate, a consensus emerged in the scientific community. We're looking at an alien megastructure, a Dyson swarm. We have just discovered definitive proof of an advanced extraterrestrial civilization. The announcement rocks the world. Governments convene emergency meetings. Religious leaders gather and discuss theological implications. Social media explodes with speculation, excitement, and fear. Scientists scramble to gather more data, to understand the nature of the Dyson swarm, and perhaps glean some insight on the civilization that built it. Are they still there? How long ago was the swarm constructed? What level of technology would be required to build and maintain such a structure? Meanwhile, SETI researchers spring into action, directing every available radio telescope towards the star in hopes of detecting some form of communication. The search for a signal, a message, any indication of the builder's intentions might be the most pressing scientific endeavor in human history. As the implications sink in, humanity grapples with a new reality. We are not alone in the universe, and compared to whoever built the Dyson swarm, we are technological infants. Our place in the cosmos has forever changed. The discovery of a Dyson Sphere would be, without exaggeration, the most significant event in human history. It would fundamentally alter our understanding of our place in the universe and reshape every aspect of human society. Let's break down some of the most immediate and long-term implications. The existence of a Dyson Sphere would confirm several key scientific and philosophical points. We are not alone in the universe. It is possible for life to evolve to an extremely advanced technological state. The laws of physics as we understand them allow for the manipulation of matter on a stellar scale. This would trigger a tsunami of new research across all scientific disciplines. Astrophysicists would scramble to understand the mechanics of the Dyson Sphere. Biologists would speculate on the nature of the beings who could create such a structure. Engineers would be inspired to think on grander scales than ever before. Even without a direct contact, the mere knowledge of what's possible could vastly accelerate our technological development. Areas that might see rapid advancements include energy production. New insights into stellar energy capture could revolutionize our power generation methods. Space travel. Understanding how the aliens manage long-term life support could boost our space exploration capabilities. Materials science. The materials used in a Dyson Sphere would be far beyond our current capabilities, inspiring new areas of research. Information technology. The computing power needed to manage a Dyson Sphere would be enormous, potentially leading into breakthroughs in quantum computing or entirely new computing paradigms. The confirmation of an advanced alien civilization would prompt a profound re-evaluation of many philosophical and religious beliefs. Some questions that would arise. What does the existence of alien life mean for our various religious doctrines? How do we define intelligence and civilization in a cosmic context? What are the ethical implications of a civilization harnessing an entire star's energy? While some might find their faith shaken, others might see the discovery as a confirmation of the universe's vast spiritual potential. We'd likely see the birth of new philosophical movements and religious interpretations attempting to reconcile existing beliefs with this new cosmic reality. Perhaps the most pressing question after the discovery would be, should we attempt to communicate with the builders of the Dyson Spheres? This would spark intense debate. Proponents would argue that the potential beliefs of contacting an advanced civilization outweighs the risk. Opponents would caution that revealing our presence to a vastly superior civilization could be dangerous. If we did decide to attempt communication, we'd face significant challenges. The 1,000 light-year distance means a minimum 2,000-year round trip for any message. How do we craft a message understandable to an utterly alien intelligence? What information is safe to share, and what might put humanity at risk? Regardless of the ultimate decision, the debate itself would force humanity to think seriously about our place in the cosmos and our long-term futures as a species. As the initial shock of the discovery wears off, humanity would need to discover the long-term implications and potential scenarios. Let's explore a few possibilities. In this scenario, we never achieve direct communication with the Dyson Sphere builders. Perhaps they're unaware of us, uninterested, or bound by some cosmic non-interference directive. Or perhaps the civilization that built the sphere is long gone, leaving behind only their monumental works. Even without direct contact, this scenario would still profoundly affect humanity. We'd have a constant reminder of the universe's potential in our relative cosmic infancy. Earth might unite under the goal of achieving similar technological feats. We'd likely pour our resources into developing our own megastructures and advancing on the Kardashev scale. In this optimistic scenario, we eventually establish communication with the Dyson Sphere civilization, and they're willing to share their knowledge. This could play out in various ways. They might share scientific principles, allowing us to advance our technology rapidly. They could offer solutions to global problems like climate change and energy scarcity. They might provide guidance on the ethical use of advanced technology. This scenario could lead to a golden age for humanity, but it would also raise challenging questions about independence and self-determination. In this scenario, the discovery spurs humanity to try to catch up technologically with the Dyson Sphere builders. This might play out as a unified human effort to advance rapidly, competition between nations or corporations to achieve Dyson Sphere level technology first, potential overextension of our capabilities in an effort to match the alien civilization. Each of these scenarios would present unique challenges and opportunities for humanity. The path we choose would depend on a complex interplay of scientific capabilities, political will, and our evolving understanding of our place in the cosmos. As we conclude this exploration of this cosmic all-sci-fi what-if, let's take a moment to reflect on the broader implications of our journey. The discovery of a Dyson Sphere would be more than just finding evidence of alien life. It would be a glimpse into the universe's potential and perhaps our own distant future. It would challenge us to think on a timescale far beyond our current scope, to imagine civilizations lasting millions of years, and to dream of engineering projects of encompassing entire solar systems. Such a discovery would hold up a mirror to our own civilization. In the reflected light of an alien megastructure, we would see both how far we've come and how far we have yet to go. It would challenge us to question our current trajectories, our use of resources, and our long-term planning, and our cosmic ambitions. Perhaps most profoundly, finding a Dyson Sphere would give us a new perspective on our place in the universe. We would know with certainty that the cosmos can produce life capable of reshaping worlds and harnessing stars. We would know the story of life and intelligence isn't just limited to our pale blue dot. And we would be faced with a thrilling, terrifying question. What role would humanity play in this grander cosmic story? As we peer into the night sky, each pinprick of light would take on a new significance. Each star would represent not just beauty and scientific interest, but the possibility of life, of intelligence and civilization spanning eons and solar systems. The discovery of a Dyson Sphere would be an end and a beginning. It would be the end of our cosmic loneliness, the conclusion of millennia of wondering if we're alone in the universe. But it would also be a beginning, the start of a new chapter in the human story, one in which we strive to understand our place in the universe grander and more wondrous than we had ever imagined. Before I go, I'd love to hear your thoughts on this cosmic what-if scenario. Here are a few questions to ponder. If you could design your own type of Dyson Sphere, what would it look like and how would it function? How do you think different cultures and different societies around the world would react to the discovery of a Dyson Sphere? If we could communicate with the builders of a Dyson Sphere, what's the first question you would ask them? How may the discovery of a Dyson Sphere change our approach to our own technological development and resource use? Do you think the benefits of attempting to contact the Dyson Sphere builders would outweigh the potential risks? Let me know in the comments below. If you liked the video, like and subscribe for more all sci-fi what if. Until next time, keep questioning, keep imagining, and keep looking up. The universe is vast and full of wonders.